tangent and cotangent are reciprocals. Secant and cosine, sine and cosecant. So we know that already. We've talked about tangent is sine over cosine, so its reciprocal cotangent is cosine over sine. Pythagorean identities we saw back in chapter 1, but we haven't really used them yet, so that is probably the most unfamiliar thing up here. The negative angles, that's with the even and odd that we talked about with graphing. We said cosine and secant were the only even functions, so if you had a negative, you could just drop it. The other four were odd, so if you had a negative, it came out. This chapter has a lot of different identities that we are going to use just to rewrite trig expressions. So you've seen the formula sheet one time in chapter 3. I gave you guys a formula sheet. Most of the identities are on here. This tab, Pythagorean identities, are on the formula sheet, so you don't have to memorize them. The others are not, because they are things that I expect you to know. We've kind of used since the very beginning the reciprocals, knowing that tangent, sine over cosine. So we've used that a lot. The only one that we haven't used a ton is if things are even or odd, but hopefully we can remember that. Cosine is even, so its reciprocal is even. And in those, you just drop the negative. So what we're going to do today, just keep your flip chart. You keep that out in front of you. It has all of your formulas that you want to look at. And now we're going to go to our notes. So we are going to start today just taking trig expressions and manipulating them into an equivalent form. Okay, you do that in algebra all the time. If I give you x plus 3 squared, you write it out twice and you FOIL it. You give me an equivalent expression. So it's kind of like doing that with trig functions. It just seems a little more foreign because we haven't done it before. In any of these identities, your angles, the x or the theta, can be degrees, radians, it does not matter, so they're always true. So if I'm asking you to simplify this, a lot of times what I'm going to say is change this to sines and cosines and simplify. So when I see cosecant, what is cosecant? What's the definition of cosecant? It's the reciprocal of sine. So I am rewriting cosecant as 1 over sine x. Now today we're just practicing manipulating these, but later this week we're going to be doing proofs. And in a proof, if you remember from geometry at all, your answer is the work that you do. So this is the time where showing all of your steps is important. That is the justification. You are justifying this so that anyone that picked up your paper could understand how you got from point A to point B. Minus. Okay, if I'm just going to sines and cosines, I'm going to leave cosine x as it is. Times cotangent. How would I write cotangent using sines and cosines? It's 1 over tangent, but what if I want to go with sine and cosine? And just make sure you are putting those arguments. So we put cosine x over sine x. Okay. So if I'm trying to simplify this, if we want to focus on order of operations, that means we have to multiply. This is like cosine over 1. So if you multiply, you just multiply the tops. Cosine times cosine is cosine squared over sine. Okay, if we want to add or subtract fractions, they have to have a common denominator, but if we look, these do. So I can put this together as one fraction. Minus cosine squared x over sine. Okay, 1 minus cosine squared. We can do a little bit more with that. If you look at our identities, this one has a cosine squared in it. If you manipulate this identity and subtract the cosine squared over, that that means 1 minus cosine squared is equal to sine squared. Do you guys see that? So you probably wouldn't have recognized it right now, but after we do it several times, you'll get to that point. 1 minus cosine squared is sine squared. So I have sine squared x divided by sine x. And what happens if you take sine squared and divide it by sine? What do you get? Saying you have 2 sines on top and 1 on the bottom, so one of them cancels. So what that tells us is this original expression is really equivalent to sine x. It's kind of like algebra, except with trig functions. We are going to use those identities to help us rewrite things. And really, the whole point today is just practicing manipulating them so that when we get into proofs, we're a little more familiar with it. All right. Any questions on that one? I have 1 plus cotangent squared x divided by cotangent squared x. There's really a couple different options for how we might start this problem. Any thoughts? If you wanted to do that, you would have to break them into individual terms. So you would have to write it as 1 over cotangent squared x plus cotangent squared x over cotangent squared x, which we can do. There's really, I guess, probably 3 ways to start. So this is an option. 2 terms on top, only 1 on the bottom. So if you break it apart, 1 over cotangent. What is the reciprocal of cotangent? So 1 over cotangent squared is the same thing as saying tangent squared x. Plus cotangent squared divided by cotangent squared. Anything divided by itself is 1. Look at your formula sheet. Tangent squared x plus 1. What is that going to be equal to? Final answer is secant squared x. Is that one okay? Keep working. Secant theta plus cosecant theta times cosine theta minus sine theta. Whoa. Oh, that is
It's me.
Thank you so much.
Yep. I don't think they're safe in there.
Go walk away.
Yeah.
All right. What are your thoughts? If it were like, well, let's just, if you don't know what else to do, change the sines and cosines. What is secant? What is cosecant? Times cosine theta minus sine. So this is multiply. That means we can FOIL here. What happens if you take 1 over cosine times cosine? It just leaves you with a 1. 1 over cosine times negative sine. So if this is like sine over 1, you multiply the top, so it's negative sine over cosine. You're writing the theta with each of them. I don't always say it, but you should be writing it on every step. 1 divided by sine theta times cosine theta. Maybe cosine theta over sine theta. Minus 1 over sine times sine. The sines cancel and just leave us with 1. What happens to my 1s? Those cancel. Sine divided by cosine is tangent. So we have negative tangent theta plus cosine over sine is cotangent. So you could write it as that, or if you wanted, you could switch it and make it cotangent theta minus tangent theta. Either is fine. So we're just simplifying as much as we can. When in doubt, change the sines and cosines. Two more for today. So first I want to explain what this means. When you see that cosine squared, it's saying 1 minus the cosine of negative theta, and it's squaring that whole thing. Okay, it's just a notation, they write it after the cosine. So when it's, this means 1 plus tangent of negative theta, and squaring that. Now cosine is even. What happens if there's a negative on the angle? It drops. So this just turns into cosine squared theta. Now tangent is odd. So that means the negative gets pulled out in front. But it's still squared. What happens if you square a negative? Goes away, becomes a positive. So this turns into 1 minus cosine squared theta over 1 plus tangent squared theta. Alright, look at your formulas. Whenever I have squares, I'm looking at those Pythagorean identities. 1 minus cosine squared. What is 1 minus cosine squared equal to? It's what we had when we manipulated this first one. 1 minus cosine squared would be the same as sine squared. Okay, what is tangent? 1 plus tangent squared. Alright. Technically you could leave it like this, but let's say I told you to write your final answer with sines and cosines. Secant is 1 over cosine. How do you divide fractions? So that becomes cosine squared over 1. So it's just sine squared theta times cosine squared theta. So that original 1 is equal to sine squared plus cosine, or times cosine squared. final problem for today. This looks really ugly. But we know if we want to square that, it means you have it written twice. And you have to FOIL. So sine x times sine x would be sine squared x. Outside, sine x times cosine x. Inside, another sine x cosine x. Last, cosine times cosine is cosine squared. Minus, and now I FOIL the next one. So sine x times sine x is sine squared x. Sine x times negative cosine. Negative sine x cosine x. Negative cosine times sine. Negative sine x cosine x. And negative cosine times negative cosine is positive cosine squared. If we're subtracting, what do we do with that negative? We just preview. And then we look. We have a negative sine squared and a positive sine squared x. So those cancel. Positive cosine squared x and negative cosine squared x cancel. Then I have sine x cosine x 4 times. So when you add those, you just add the coefficients.